Good morning students. Our today's chapter is polynomial and topic is quadratic polynomial and relationship between their zeros and the coefficients. Before we shall go to the topic, I want to define some important terms related to the polynomial. Number one, degree of a polynomial. If p of x is a polynomial in variable x, then the highest power of the polynomial in x is known as the degree of polynomial. Polynomials are of different types. Example, constant polynomial. 2, 3, 4, minus 7, 8, root over 2, etc. are the constant polynomial. A constant polynomial does not have 0. And the degree of a constant polynomial is 1. Zero polynomial. 0 is known as the zero polynomial. That is, p of x equal to 0 is a zero polynomial. And the degree of a zero polynomial is not defined. And every real number is a zero of zero polynomial. Linear polynomial. A polynomial whose degree is 1 is known as linear polynomial. General form of a linear polynomial is ax plus b equal ax plus b, where a and b are real numbers and a is not equal to 0. And the degree of a linear polynomial is 1, and therefore the number of the 0 of this polynomial will be 1. Let p of x equal to ax plus b and k be the 0 of the polynomial. Then p of k equal to 0. This implies ak plus b equal to 0. This implies k is equal to minus b by a. That is, the 0 of the polynomial ax plus b is minus constant term by the coefficient of x. Similarly, a polynomial whose degree is 2 is known as the quadratic polynomial. Its general form is ax square plus b plus c, where a, b and c are real numbers and a is not equal to 0. And the number of degree of this polynomial is 2. Therefore, a quadratic polynomial can have 2 zeros. And that is, the maximum number of zero of a quadratic polynomial is 2. A quadratic polynomial cannot have also 0. What I shall explain later on. Cubic polynomial. If a polynomial whose degree is 3 is known as cubic polynomial. The general form of a cubic polynomial is ax cube plus bx square plus cx plus d, where a, b, c and d are real numbers and a is not equal to 0. And the number of degree of this polynomial is 3, and therefore the maximum number of zeros of this polynomial will be 3. Later on, we will find the relation between the zeros and the coefficients of a polynomial and the zero and the coefficients of a quadratic polynomial and cubic polynomial. Now, I would like to suggest you, whenever you go to this chapter, first of all, you will read introduction to this chapter of your textbook, where you will find everything what I have defined now. Now, let us go to our topic. First of all, I am going to write some important points related to the quadratic polynomial. Key points related to quadratic polynomial. Number 1, the general form of a quadratic polynomial is ax square plus bx plus c, where a is not equal beta p two zeros of the polynomial ax square plus bx plus c where a is not equal to 0, then alpha plus beta is equal to minus b by a, that is sum of zeros equal to minus b by a equal to minus coefficient of x by coefficient of x square, and alpha beta c by a, that is product of zeros equal to c by a, that is constant term by coefficient of x square. 3 number. This part is very important for this topic. If alpha and beta are the zeros of a quadratic polynomial in the variable x is then the polynomial is defined as x square minus alpha plus beta into x plus alpha beta. X square minus within bracket sum of zeros into x plus product of 0, that is x square minus sum of zeros into x plus product of zeros, and this can be written as x square minus b by a x plus c by a, and so on. Now maximum number of zeros of a quadratic polynomial is 2. 5. A quadratic polynomial ax square plus bx plus c where a is not equal to 0 has a real 0 if and only if b square minus 4ac greater than or equal to 0. 6. A quadratic polynomial ax square plus bx plus c where a is not equal to 0 has not 0 if b square has not a real 0 if b square minus 4ac is less than 0. From these two concepts, you can confirm that the given quadratic polynomial had 0 or not. You will take the coefficients of x square as a coefficient of x is b and this is constant term. You will put the value of a, b and c here. If your result is greater than 0 or equal to 0, it means that the polynomial has a real 0. Otherwise, if you are getting b square minus 4ac and less than 0, it means that that quadratic polynomial has no 0. These are some important points related to the quadratic polynomial, and whenever I shall show some questions, that time I shall explain if I shall find another points related to the chapter. Now I am going to show some different questions related to the quadratic polynomial from textbook. Exercise 2.2. Question number 1. Find the zeros of following quadratic polynomial and verify the relationship between the zeros and the coefficients. Number 1, we have x square minus 2x minus 8. This is already in the form ax square plus bx plus c, and ax square plus bx plus c, where a equal to 1, b equal to minus 2 and c equal to minus 8. We have to find the zero of this polynomial. To find the zero of this polynomial, we have to find the factors of this polynomial, that is, we are going to factorize this polynomial, and we will factorize at x square, and we will split the middle terms to find the factors of this polynomial, what you have already got in the previous classes. And x square, once again I am going to explain here. Coefficient of x square is 1, constant term is 8, 1 into 8 is equal to 8. Here this is negative sign, that's why we will write here negative sign. If this is positive, then we will write here positive. If this is negative, then we will write here negative. It is very simple to understand. Now we have to find two numbers whose product is 8 and difference is 2. 4 into 2 equal to 8 and 4 minus 2 equal to 2. And therefore we have to take 4 and 2. We have 4x minus 2x. And you cannot write here 3x minus 1x. 3x minus 1x will give 2x, but the 3 into 1 will not be equal to it. That's why we will split the middle terms in such a way the product of the coefficients of the two middle terms should be equal to the product of the coefficient of x square and the constant. And the difference between these two terms should be equal to the middle terms. Now let us remove the bracket. X square minus 4x minus into minus plus 2x and 8, and we will regroup first two terms and the last two terms, and then x square minus 4x, this is plus, that's why we will not change the sign of these two terms. 2x, without changing we will write the terms here because we are taking here plus as common. Now x is the common of these two terms, x minus 4, 2 is common factor, 2 into x minus 4. This implies x plus 2 into x minus 4. Here binomial is the common factor of these two terms. the value of x square minus 2x minus 8 is 0 when x plus 2 equal to 0, this implies x equal to minus 2, and x minus 4 equal to 0, this implies x equal to 4. And therefore, minus 2 and 4 are the zeros of x square minus 2x minus 8. Now, second part of this question, we have to find the relationship between the zeros and the coefficient. Now, sum of zeros equal to minus 2 plus 4 equal to 2 by 1. Here we have already learned that the sum of 0 is equal to minus b by a, and this is plus. That's why we will have to express as minus something by coefficient of x square. So this is plus 2 and this can be written as minus into minus 2. We can write, because minus into minus is equal to plus, and that's why we will have to write here minus 2 by 1. Now let us go to the polynomial. The minus 2 is the coefficient of x and 1 is the coefficient of x square, and therefore we will write here coefficient of x by coefficient of x square, and product of zeros equal to minus 2 into 4, this implies minus 8 by 1. Here minus 8 is the constant term. We will write here constant term by coefficient of x square. These are the relations between zeros and the coefficient. Now I am going to show question number 3 of question number 1. Three. 6x square minus 3 minus 7x. 6x square minus 3 minus 7x. Here, this is a quadratic polynomial because its highest degree is 2. But this is not in the form of ax square plus bx plus c. I can write it in the standard form as 6x square minus 7x minus 3, because it is not in the proper order as ax square plus bx plus c. Now it is in the proper order, and this is in the form ax square minus plus bx plus c. Here 6 equal to a, minus 7 equal to b, and minus 3 equal to c. Now once again, I am going to find the factors of this polynomial by splitting the middle terms, and 6x square minus, once again we will write here 3. This is negative sign, that's why we will write here negative sign. Now 6 into 3 equal to 18, and we have to write, two numbers whose product is 18 and difference is 7. Obviously the numbers are 9 and 2, because 9 into 2 is equal to 18 and 9 minus 2 is equal to 7. That's why we will write here 9x minus 2x, which satisfy the condition that 9x minus 2x is equal to 7x, and 9 into 2 is equal to 18, that is 6 into 3 is equal to 18. Now let us open the bracket. 6x square minus 9x plus 2x minus 3, and we will regroup the first two terms and the last two terms. 6x square minus 9x plus 2x minus 3. 3x is the common factor. 3x, 3 2 is x, 3 3 is 9, and here 1 is common factor. 2 2x minus 3. This is 3x plus 1 into 2x minus 3. 2x minus 3 is the common binomial to these two terms. So, the value of 6x square minus 7x minus 3 is 0 when 3x plus 1 equal to 0. This implies x is equal to minus 1 by 3, and 2x minus 3 equal to 0. This implies x equal to 3 by 2. Therefore, minus 1 by 3 and 3 by 2 are the zeros of the polynomial. Now, I am going to find the relations between the zeros and the coefficients of the polynomial. A relation is between zeros and coefficients. Sum of zeros equal to minus 1 by 3 plus 3 by 2. You already know how to add the two rational numbers. 3 to the 6 LCM, minus 2 plus 9, 7 by 6. Here the sum of the zeros should be negative of b by a. That's why we will write here minus 7 by 6. You can check here. This is the minus 7 is the coefficient of x, and that's why you write minus coefficient of x, and 6 and 6 is the coefficient of x square, and product of zeros equal to minus 1 by 3 into 3 by 2. This is minus 3 by 6. Minus 3 is the constant term, 6 is the coefficient of x square, of constant term by coefficient of x square. This is the relation between the zeros of the polynomial and their coefficient. Rest you can try to do yourself. And now I am going to question number 2. Here, find the quadratic polynomial each with the given numbers as the sum and the product of its 0. 1. Sum of zeros equal to 1 by 4 and product of zeros equal to minus 1. This minus 1 can be written as minus 1 by 1. Now sum of zeros, what I have already explained. We can write minus b by a equal to 1 by 4, and this implies that minus c by a equal to minus 1 by 1. Here we can observe that a equal to 4 and here a equal to 1. They are not equal. Even they should be equal. Then how we will make the equal? Then obviously we will find the LCM of 4 and 1, and the LCM of 4 and 1 is 4. That's why here it is already 4, and to make something by 4, here we will multiply 4 by numerator, and we will multiply both numerator and denominator by 4. That's why I am going to write here minus 1 into 4 by 1 into 4, that is minus 4 by 4. Now this equal to this, because A equal to A. Now let us write the value of A, B and C from these two terms. So we write A equal to 4, minus B equal to 1, because this is the minus B, this is 1. That's why we will write minus B equal to 1. That means B equal to minus 1. We will write here the value of B, and C equal to minus 4. This is the minus 4 which is equal to C. So the required quadratic polynomial is given by ax square plus bx plus c. This implies A, what is the value of A? 4. 4x square. What is the value of B? Minus 1. So minus 1x. What is the value of C? Minus 4. That is 4x square minus x minus 4 is the required quadratic polynomial. Here I am going to take one another example which is not given in this book. From that, your concept will be clear. Two number, additional sum, given sum of zeros equal to 2 by 3 and product of zeros equal to minus 5 by 4. These are the sum of zeros and product of zero. You can write any numbers here. Now, minus b by a equal to 2 by 3 and c by a equal to minus 5 by 4. Now let us see here what is the value of a in the first term and what is the value of a in the second one. The value of a is 3 and this is 4. They are not equal. How will you make them equal? We will make them equal by taking the LCM of 3 and 4. The LCM of 3 and 4 equal to 12. That's why we will have to write here something by 12 and here also something by 12. I am going to write minus b by a and something by 12. To write here 12 we will multiply 4 to the denominator. At the same time 2 will be multiplied by 4. 4 to the 8 by 12. And here we will multiply both numerator and denominator by 3 because 4 3 is 12. 4 minus 4 3 is 12. Minus 3 into 5 is equal to minus 50 and 4 3 is 12. Now the value of A are the same. We get A equal to 12, B equal minus B equal to 8, therefore B is equal to minus 8 and C equal to minus 15. Minus B equal to 8, therefore B is equal to minus 8, we will write here B and C equal to minus 15. Therefore, the required quadratic polynomial is equal to ax square plus bx plus c. That is, what is for A? 12, x square for B minus 8x and for C minus 15. Now, you will try to do yourself the remaining questions of exercise 2.2. Today only this much. See you in the next class for the rest.